So, hello everyone. My name is Jakub Čajka. I'm software engineer working at Red Hat as part of the Fedora multi-arch team. I'm responsible on working on support of the multi-arch in Fedora, making all the stuff on par with other architectures. Apart from that, I also maintain Golang, and for some time I also maintain Golang as part of the RHEL. So that's for my brief introduction, and today I will be talking about Fedora CoreOS and how to build it and how to run it. So you can try it for yourself and help us build CoreOS for you. So what's CoreOS at all? Maybe a brief question for audience. Who knows Fedora Atomic Host or Atomic Host? And who knows CoreOS Container Linux or used it in some way? So few of people here, quite few. So basically, Fedora CoreOS is offspring of the Fedora Atomic and CoreOS Container Linux. As CoreOS, the company got acquired, I believe, a year and a half ago by Red Hat. This Fedora CoreOS is building on the technologies of both of the Linux distributions and its merger. For example, from Fedora side is RPM OS3. From the CoreOS side is Ignition. I will dive into those a bit later. Just to briefly summarize what's the general aim of the Fedora CoreOS is basically immutable general purpose minimal container focused server Linux distribution. So that allow you to use it for many things that you wish, including running containers in simple way via Podman or in real production environment as part of the Kubernetes or OpenShift. And it's upstream for the I believe currently single-purpose Red Hat CoreOS, which is powering enterprise OpenShift. So a few more points on Fedora CoreOS. Unsurprisingly, it's composed of the Fedora RPM packages. So from the multi-arch side, it makes the life easier. So you do not need to rebuild everything and port and work on it because it's already there. It's kind of rolling distribution that plans to have multiple streams, like the production release versions, development with multiple branches like testing, directly what just got built, and many more. It targets various cloud providers, so you can run it in AWS and others, and also all Fedora support architecture, not just Intel. That's my part that I'm working on, and others that are contributing to that. And in the future, it might be based on other immutable Fedora spins as Silverblue and other really taking the part of the Atomic host. So to the technologies, the RPM OS3 is the technology that was used in Atomic host. It origins there. Basically, like oversimplified, it's just a snapshot of the RPMs from Fedora that you just track, and you can apply atomically, like updates, rollbacks to known state that you can transfer between different deployments, different places. So you know the state of the system basically. So I'm not surprised. Ignition, that's the technology from the CoreOS side. It's a way how to configure the system. So you have an immutable system, but you need to configure something. So on first boot, it runs. It accepts ignition file, which is basically a JSON file with all the information that you want to do on the first boot to configure it, like what services you want to run, what users you want to have with which secrets, injecting SSH, public SSH keys, it's run just on the first boot, and the config is provided from some central place. You host it somewhere, and it gets there. Or you use the provisioning capabilities of the cloud provider you are running, the VMs, the hosts, and it's available by the other means. And to mention, there is also a tool in CoreOS GitHub, FCCT, that if you do not want to write JSON, you can write YAML that gets translated into JSON. Just to mention that. Zincati and Cincinnati. One of the things of the container Linux, the CoreOS container Linux, was that automated updates and rollouts with different strategies. So you didn't need to care about your Linux. It just get updated, and if it didn't work for some reason, it got rolled back to some working state. So these are the projects and that are going and are facilitating this in Fedora CoreOS. Yeah. The other bit that we are getting from like the technologies used in the CoreOS, a bit more to the low level, that will be you see during the building. I will mention it. Is the Mantle framework, which is other bit coming from the Condor side, and it's basically glue that provides different tools for building, running, uploading the resulting artifacts to different cloud providers. And many, many more, basically a set of scripts and utilities that are used. That's other bit of the stack. And basically this is the whole overview of the most important bits and pieces in CoreOS with all the respective GitHub projects. So feel free to go there, grab it, try to break it, report issues. It will be really great, or features that you are missing. So this is the basic overview of the CoreOS, and let's move forward building it, because it's not really using the generic tools that are used in Fedora for building other images and other distribution artifacts. The core piece here is CoreOS Assembler, which is a set of tools to build the resulting images of the distribution. It actually, all of it lives in container. It builds into container. All the pipeline of the Fedora CoreOS are built based around it. I will definitely mention the README file in the GitHub repo. Really read it. It has great start, but I will walk you through the steps to build it. One mention, I will be talking about this command. CACOSA. It's basically a small script wrapper function in Bash that helps with invoking the container and running all the stuff. It's based on the Fedora base image. It's building on top of Fedora container image. It's specific to each architecture, so you need to build it for each architecture at the moment. In future, it might change, but it's not really yet clear. There is a Docker file from which you can just build it yourself using your tool of choice. Docker or Moby should work both as Podman, which Podman is used by the upstream by the Fedora CoreOS. All the steps of the build are run in the container, and all the data that are coming out of it and in are bind mounted into it. So you need to conserve for it in some ways. You will see during the build, but it's not really that hard or complicated, and it's really ready to be run on the platform, on the container platform we're choosing, like whether OpenShift Cube or something else. One thing to mention, during the build, you will need working virtualization. You need to have KVM working on your host, apart from having the container runtime. In many ways, you can basically follow me now through the whole building process. It should be possible if you have a laptop here, with Linux that have KVM. You can basically now, like not probably in the time frame of the talk to build it. It will take 45 minutes to finish with all the downloading and stuff like this. But to build the CoreOS for yourself and start hacking on it, whether on your laptop for Intel or for other architecture in some machine that you have somewhere in data center or in cloud. So I will start with showing off just the basic start that you will do, which is clone the CoreOS assembler. There's really nothing more to it. You need to initialize in the repository submodules because the mantle, or the framework holding all the bits and pieces together, and some other components are as part of submodules, so you need to download them too. And after that, you can just use the tool, the container tool of your choosing, that can work with Dockerfile to just build the image, to assemble the image. It will take some time. I will probably skip all the steps, but it basically downloads all the tools that are needed, builds the tools from the mantle, and then that's it. Yeah, that's really all of it. It will take like 10 minutes just building from the scratch, and actually this is from Power Machine. So I will now skip this because it just really builds the container and it just works. So now we are moving more to the CACOSA wrapper and like initializing the environment and setting and getting the configuration because the CoreOS assembler tool is ingesting the configuration which lives in this GitHub repo. It basically says what artifacts are coming into it, and that's probably first, like with current situation, is probably the first place where you'll be hacking on the OS to get stuff that you want in the development environment. So to show it. Oh, and one thing that I need to mention is the CACOSA wrapper or wrapper script, which I will enlarge it. That I need to mention as which is really shell script snippet, really small, that's mentioned in the README. On top of this, I just export variables like what container I will use to build it, and some parameters to QEMU to use more memory. I believe it's no longer needed. And it itself, on its own, it just simplifies invoking the container tool of using here Podman for running the container and running the build process. It said whether it will run in privilege mode, where the config will be, and other arguments. So it's not really much of the black magic, and it's actually is described in the README file or more thoroughly. So with that said, you basically source into your shell the snippet that will enable you to call the CACOSA command, and like the first part is just getting the initializing the directory, and it will download the configure for you that you specified. And that's just the first step. You have the configuration files files in the directory in src config, and there lives the whole config, all the bits that define what goes in. So after initializing, you fetch all the bits that will be used in build. There's nothing really much to it. It will download all the RPMs that will be used for the build. Again, like sourcing it if you have not done it prior, and just CACOSA fetching. It will run for some time. It will be like another 10 minutes, and it will download all the bits into the local environment. So here, it will just really run for a bit. Yeah, you can see it's running in QEMU. That's just booting VM into which all the things are passed through via the container. Yeah, it's really downloading stuff. You can see it's for PowerPC, and in the end it just exits. I will just skip that to get to the bit more interesting part, and this basic build that will prepare the basic image, which is the QCOW for QEMU. Again, it's just easy invocation via the wrapper. It works currently on Power with all the work for past few months from me and others. You need the CACOSA, and it just builds. It will create the OS tree, commit it, prepare the kernel configuration, the Jakub setup, and generate the base image. Well, download other bits. And this will take some time again. I believe I can skip most of it, and it's processing the packages and installing them into the image. And it will take some time. I think it's when you will run it for yourself, you will see there's not much of note here. Just it takes some time again. And after the successful build, which should be successful at current state, you can just run it. So I need the CACOSA command that I have here, and then you can run the finished image. It will inject the ignition, the default ignition that's specified in the scripts, which will just automatically log in user CoreOS on the default terminal here for the P-series QEMU machine. It's booting, and it's up. You can see that we are running fairly recent build of kernel. We are using RPM OS3 to managing the packages, the system. And you can see that we are actually running build from today, from the morning, that I built on the machine, on the Power machine that I have here. Yeah, it's Power 9 machine, and the QEMU has 16 cores dedicated. So we can shut it down. So basically, that's the minimal stuff to get into trying it on your development machine, whether Intel or Power, ARM, or even mainframe. There's a bit more to the tool. There's actually built extend command that takes the base build and extends it for other platforms or cloud providers, for for booting via the Pixie, via the installer, or running directly on bare metal, running on the OpenStack. So it takes the default image, and for Pixie, it extracts the kernel and initram fs. For bare metal, it just converts the image. For OpenStack, it's do a bit more magic, and for other cloud providers, especially on Intel, it do its stuff too. And you will have the artifacts ready locally, so you can try it. So the current status, I'm working on putting out unofficial builds for the multi-arch. So we are a bit further from the official builds, because we will need to work on the pipeline and the infrastructure, so we can build it on Power and other architectures. Currently, you can build it and run on P-Series on PowerPC just fine. You can also try it on AR64 and System-Z if you are interested. My current focus, apart from the working on the infrastructure and like setting up official builds for the multi-arch, is work on testing and trying out other targets as OpenStack and verifying that everything is working also on PowerNV, on bare metal, in PXE environments. And technically, it should just work fine. But yeah, someone needs to try it, because yeah, if it builds, it doesn't mean it will work, or it will work without issues. So also, if you have bare metal PowerPC and you have some spare time and you are interested in it, I'll be really happy to help you to try it out for yourself. Or even other architectures, if you have like bigger collection of the machines at home, not just some small power to socket system with lots of core and lots of memory. Or if you also have some mainframe lying around, for example, I will be also happy to help you with that. So that's basically it for today. I will much appreciate if you get involved, if you help us to know what you would like to use CoreOS for. If you have some specific use cases that are not covered, or you think there are things that we can do better, or I can do better. And yeah, thank you very much for your attention. Here you can see there's mailing list upstream. We have Discuss. There's issue tracker for all the stuff going around Fedora CoreOS. There's Freenode. There is IRC channel on Freenode, and there is official download location for the Fedora CoreOS. Unfortunately, now it's just Intel. And yeah, that's really all from my side for today. Thank you very much.
Great. I have the microphone, so I get to ask the first question, and then I'll let you guys ask
and the questions, yeah.
Yeah,
come ahead.
Question time. So, forgive my ignorance, but I didn't follow completely what happened to the sort of where the original CoreOS community was. And it sounds like what you're describing is that as CoreOS was acquired by Red Hat, they've essentially moved that community into Fedora such that it's a part of Fedora, as you described. Is that saying then that delivery of what CoreOS was delivering and doing as a community is completely integrated into Fedora, and therefore there's nothing that sort of remains of the old community? It's now a Fedora-based community, and that's what's happened with it? Is that the right way to think about it? If not, how would you explain what's occurred?
I would say like it's probably the right thing to think about it. That's my understanding too. I'm not sure if there is not a remnant of something of the old CoreOS, but that just my understanding is the same as yours, and we've been working with.
And then the follow-up question is, if I read your statement about Atomic, right, they sort of do similar things at a high level if we think about them.
Yeah, in the Fedora.
That over time we might expect that Atomic will do less and CoreOS will slowly take over.
In Fedora space is basically the Fedora Atomic host is superseded by the Fedora CoreOS.
Replaced, superseded, dead maybe to,
It's still live on in the server rule for a time. And my understanding is too that it will eventually might get there. The Fedora CoreOS might get there.
Okay. So tracking Fedora, CoreOS over Atomic would be, for people wanting to pay attention to where we're going in the container space.
Yeah, and really there's lots of development going on, so I wouldn't say like everything is different every day, but there's lots of things going on, and I believe there's great time and great place to get involved and get your use cases covered.
Yeah. Now, one final question, and that is, my original understanding was that CoreOS largely was built on Gen 2 tools and the Gen 2 type environment. Is that an original understanding?
I'm not that familiar with the original CoreOS, unfortunately, so I cannot really, I really don't want to comment much on that. Like currently, it's really built mostly on the Fedora packages and with its own tooling, which is a bit different than like the regular, let's say, release processes for Fedora or Fedora release tooling. And I believe they have similar processes, but with different tooling. So, yeah, as you've seen, you can really easily replicate the build of the system like locally, which is not that easy for regular Fedora artifacts. If you want to build your own image, it's not that. Not that easy. Like really, you just.
Thank you for humoring.
In 45 minutes, you can get your own CoreOS.
Who has a question besides me? Somebody's got a good idea. Anton's got a good question here. I'd be worried.
I'm not sure it's a good question. This is really cool stuff. I just was going to ask, and it's a common theme I've been asking, I guess, everyone at this conference. I mean, anything on the software side or the system side? I know you've done guest support. You're looking at Power and B now. Any issues? Things you don't particularly like, or
like from my personal side, because I from various sources acquire a few P8s, and there's a slight issue with nested virtualization.
Oh, okay, yeah. So nested virtualization on P9 is much better. Definitely.
I need to retest it. Like really, it might have. Yeah, I have not yet tested with all the latest stuff.
Well, I was going to say that the recent stuff that Paul and his team did, I think they got up to 12 layers of nested virtualization before it all slows down. So,
as you've seen, it's running in QEMU KVM, which may be worrying if you're running all the kernel now, if it's already taken care of.
Yep.
That on like all the P8s, if you have just VM, it might not have worked. It might just hanged and. Nothing would happen.
Yeah, that's one thing that did get much better in P9, and the Radix nested virtualization is much better than what we had in P8, definitely.
That's all. He just wanted one thing. Boy, that's good.
Anything else?
Anything else?
Otherwise, I cannot really think like that. I had any issues on Power related.
Without the mic. No. Okay. I wanted to know if your target is mainly containers, or if you intend to have a bare metal implementation of CoreOS?
I believe CoreOS is targeting both running as virtual machine in cloud and also as running on the bare metal host. And like the focus is mostly on running container on top of it. Yeah, if I have been misspoken.
And you run container on a CoreOS that runs a machine.
That runs whatever your workload is, whatever it might be like KubeVirt if you want to run like virtualization inside a container or something, or just literally just running QEMU. It might be the case if it's something that you want to do.
Okay.
And really, like the Fedora CoreOS is really general purpose. You can do whatever you want, and I believe the folks in upstream will be happy to hear what you want to do and see what they can do for it. For example, I believe still is ongoing discussion if there will be some default supported containerization, like container platform like Kubernetes or OpenShift or something else, or if there will be something or not, or how it will be done. So that's one of the discussions that's going on in the upstream, and that's someplace that you might get, you might provide some feedback and you might be interested of all of us.
Yeah, the bare metal use case for CoreOS is an interesting one to contemplate. It's a good question, Francois.
Yeah. Thank you.
Danke. Other questions? I think everybody should go pull their container CoreOS and do a build tonight. All right. Thanks, Jakub. Let's give him another round of applause.
Thank you.